In this set of notes, we're going to talk about how we can subdivide a segment into different ratio parts, or really partition it into different sections. So a directed line segment is a segment between 2 points, A and B, with a specified direction. So from point A to B, or you could go from point B to A. Most of the time, we're going to go from A to B, so from left to right. To partition a directed line segment is to divide it into 2 segments with a given ratio. So here are the steps that I want to make sure you guys get written down and that you have in your notes. So the steps for finding the coordinate that subdivides the segment, we need to go from left to right. We're going to count the rise and run on the graph. Then we are going to divide those numbers by the first number, or the number of equal pieces in our segment, and I'll show you how to do that. Then we're going to take that rise number and we have to multiply it by that first number in the ratio, because we need to have that portion of the ratio. So if it's 3 to 1 or 5 to 3, we need to use that very first number. Then the run number, we are also going to multiply by it. We also have to notice what direction we are moving. And then we're going to take that and add it to the left coordinate, because that's where we're starting, and we're going to use that to find what the new coordinate is going to be. So remember, if you ever get stuck, take a look up here, and we're going to be mentioning the different steps. So when we're looking at this, again, we need to know what the ratio is. And if you notice, we are graphing these 2 coordinates. We want to find the coordinate, we're going to call it point Q, or point P, I guess, and it needs to be 3 to 1. So the ratio of 3 to 1 means that there are going to be 4 equal pieces. So in our segment, if we divide it up into 4 equal pieces, that would mean that our coordinate is going to be 3 of the spaces away from one side and 1 space away from the other side. So this is our 3 and this is our 1. So notice together there are 4 equal pieces. So that's what you're really trying to do on your coordinate graph, and then find where this one coordinate is going to end up. So we need to divide up our graph with our rise and run. So count from A to B. So if we count, we went up 12 and we went to the right 16 spaces. So we need to know the direction as well. So our rise is 12 and our run is 16. And remember, the rise is always your y values, run is always your x values. So we're going to take those numbers and we are going to divide it by our equal parts. Our equal parts are 4. So divide both of those by 4. That gives me a 3, and that gives me a 4. Next, I need to multiply it by the first number in my ratio, so that would be 3. So I get a 9 for this number, and I multiply it again by that first number in the ratio, so 3, and I get a 12. Now remember, the run was going to the right, and our rise was going up. So it all comes from those first directions when we first counted them. So next, we are going to take the left coordinate, so it's starting at coordinate A, and we need to figure out if we divide up this length into 4 equal pieces, we want to find where that third coordinate will be from our endpoint A. So when we start at coordinate A, that is at -8, -7, I need to use my run number, so to the right 12, and that means I need to add 12 to my run. So that's my x value, and when I take -8 plus 12, I get a positive 4. Now I'm going to do the same thing for the run. So since we're going up 9, and when we graph something, if we're moving up, we are adding. So I need to add 9 to my y value. So -7 plus 9 is a positive 2. So if I graph that coordinate on my graph, that means that this is 3 equal pieces and this is 1 equal piece. So this is my point P, and that is at 4, 2. So one thing you could do to see where the other coordinates would end up on this line is, if we know that they need to be divided up into 4 equal pieces, this number back over here, my rise is 3, my run is 4. So if I count up 3 and over 4, there's 1 dot. Up 3 over 4, there's another one, and then I still end up at that same spot for my point P, and then my B. So if you notice, there are 1, 2, 3 sections here, and then there is 1 on the other side. And that's where this 3 to 1 comes in with your ratio. So if you do find the other coordinates, there's your proof that you did find them correctly. On number 2, if you go ahead and graph your point D and E, Now, the ratio is going to be 5 to 3, so I want you to fill in how many equal pieces there should be on our segment. 5 to 3 means that we are going to have 5 sections on one side of your point P, and you're going to have 3 sections on the other. So that means there will be 8 total. So if I cut this in half, that would give me 1, 2, 3, 4, and then we have 5 on the other side. So if you notice that the spacing, I would have 8 sections evenly spaced out. You would have 5 on one side and then 3 on the other, and then that's where our point P is going to end up, and that's what we need to find. So it's 5 sections away from point D. So next we need to count our rise and run. For our rise, we had to go down. For the run, we had to go to the right, and if we count that, our rise is the 9, run is 10. So let's put those over here as well. So rise was down, run was across to the right. Remember, your rise is always your x, your run is your 10. So now if we divide it by the number of equal parts, that's our 8 up here, we get a fraction. So we need to leave it as 9 over 8, and this we can leave as 10 over 8. Next, we need to multiply it by the first number in our ratio, so that is 5. So when we multiply it by 5 over 1, remember, you go straight across, so that gives us 5 times 9 is 45, and 8 times 1 is 8. The direction of our rise was down, so we're going to have to subtract 45 over 8. And since we are moving up and down, that's affecting our y value, so we will need to subtract that fraction from our y value. Next, for the run, we need to take our 10 over 8 and also multiply it by that first number in the ratio. So we multiply by 5, and I want you to tell me now, what does that number equal? All right, so 10 times 5 gives us a 50, over 8 times 1 is 8. If you reduce that, we could get 25 over 4, and we are moving to the right that number of spaces. Since we are moving to the right, we are going to be adding that number to our x value. So the x value we are starting at, remember, is the one on the left, and that's our point D. So I'm taking my negative 3, 6, and now I need to add 25 over 4 to it, to the x, and I need to subtract 45 over 8 to that fraction. Remember, you can use your calculator to do this. When you do, you get 3.25 for our x, and the y is going to be 0.375. So that's what our point P is going to be. So once I've graphed that, if I connect that to my point E, that would mean from D to P that there are 5 equal sections in there, and then from P to E that there are 3 equal sections in there. And on this one, I'm not going to try to find where those coordinates are, just because if I need to move it, I'm going to have to move it a little bit above 1 and a little bit above 1 on that direction too, if you're x and your y. But this should give us 5 equal pieces, and this will give us 3. So this would be a total of 8 equal pieces between D and E.